Hello, this is Group 2 presentation of how to build a BCD adder for the class Digital Systems 1. First things first though, what is an adder chip? An adder chip is a type of circuit chip used to add two 4-bit binary numbers together. A 7483 adder chip can also be used to add two BCD numbers together. But what would happen if the number was bigger than 9? It would not accurately display the number that we were looking for when we do the addition. How do we solve this? In order for a BCD number larger than 9 to be accurately displayed, we would have to add 6 to the binary. In order to create a BCD adder, we must first create these 3 parts. First, binary adder, then a 9 or greater detector circuit, and then the BCD adder itself. Here is a diagram for a binary adder. Here we have a built circuit with the green wires being the B inputs and the blue wires being the A inputs, going from the least significant to the most significant, respectively. The first chip that we have here is the binary adder, with all the inputs being inside the ground for both the ground and C0, since we have no cascading chips, and the voltage. Our greater than 9 detector circuit is made up of 2 AND gates and 2 OR gates. The C4 input coming from the binary adder into the OR gate, with the other input coming from both the AND gates from the AND chip, will be able to detect whether or not the output is greater than 9. Here's the breakdown of the greater than 9 detector circuit. 2 AND gates, 2 OR gates. The outputs from both the binary adder and the greater than 9 detector circuit goes into the BCD adder. If the number is less than 9, it will be left alone in the chip. But if the answer is greater than 9, 6 will be added to the answer in order for us to visibly see an accurate BCD number on the display. Here in the physical circuit, the last 7483 chip are connected to the display to read our outputs. Currently, all of our inputs are 0. In binary, the output will be 0. Here is our truth table. A and B are both 1 through 15. So we'll be testing 1 through 4, which outputs are all under 9, and compared to 5, which is greater than 9. If this circuit works properly, it will be displayed here. Two and 2 will add up to give us 4. 3 plus 3 adds up to give us 6. And 4 plus 4 adds up to give us 8. Here, both A and B are both 5. which adds up to give us 10. This is possible because of the circuit that we have created with all the input outputs, ground, voltages, all being correct. But what would happen if our circuit didn't work correctly? For example, what if our not greater than 9 detector circuit was improperly built? What would be the output for our display? We can use the logic probe to check whether or not our circuit is accurate. Currently, the inputs are set to 1 for both A and B, and our display shows us a total of 2. In a built circuit, C4, if it is high, means that the number inputted is greater than 9. If the logic reads low, then that means that the number is less than 9. Let's take the logic probe and test whether or not the input and the output display are accurate. Our logic probe currently reads as low, which is accurate to our display and to our input. Let's try a number greater than 9. Here, the inputs for A and B are 9, adding up to a total of 18. And our logic probe reads as high, as it's connected to the C4 input. This shows us that our circuit is built correctly and is accurate in displaying BCD adders. This concludes the presentation on building a BCD adder circuit.